There is a black hole racing through intergalactic space at nearly 1,000 kilometers per second. That is already strange, but the truly disturbing part is what it appears to be leaving behind. Not destruction, birth. A narrow trail of young stars stretches across space for roughly 200,000 light-years. That is nearly twice the diameter of the Milky Way. At the front of that trail sits the signature of something moving so fast that it seems to be driving a shockwave through the thin gas between galaxies. And the leading explanation is almost absurd. A runaway supermassive black hole moving fast enough to escape the galaxy that once held it. Think about the contradiction. Black holes are supposed to be the ultimate destroyers. They tear apart stars. They swallow gas. They trap light itself. So how could one of them be followed by a nursery of newborn stars? That question is what makes this discovery so important. Because if the interpretation is right, then one of the most destructive objects in the universe may also be capable of triggering creation on an almost unimaginable scale. The story begins with a line. In Hubble images, astronomers noticed an extremely narrow linear feature connected to a distant galaxy. At first glance, it did not look like a major cosmic discovery. It looked almost too straight, too thin, too artificial, the kind of thing you might dismiss as an imaging artifact, but it was real. Follow-up observations showed a structure filled with gas and young stars, extending for about 62 kiloparsecs, or roughly 200,000 light-years. And at one end was a bright knot of highly excited gas. Something energetic appeared to be happening at the tip. So what was it? One possibility was simple. Maybe the trail was not a trail at all. Maybe it was just a very thin galaxy seen edge-on. That explanation had one enormous advantage. It did not require a black hole to be flying through intergalactic space. And in science, the boring explanation often wins. But the geometry and gas behavior created problems. The feature was unusually narrow. Its stellar populations appeared to vary along its length. The tip showed extreme emission, and the structure pointed back toward a plausible former host galaxy. Another possibility was a jet. Powerful jets from active galaxies can slam into gas, compress it, and sometimes help trigger star formation. But again, the details did not fit comfortably. The shape and the velocity pattern pushed researchers toward a more radical idea, a runaway black hole. Now, this is where the story changes from strange to extraordinary. Astronomers have predicted runaway supermassive black holes for decades. The basic physics is not science fiction. When galaxies merge, the supermassive black holes in their centers can eventually interact. In some cases, three massive black holes may become involved in a gravitational slingshot, ejecting one object at tremendous speed. There is another mechanism that is even more dramatic. Two black holes can spiral together and merge. When they do, they radiate energy as gravitational waves. If that radiation is emitted asymmetrically, the newly merged black hole can receive a recoil kick, a kick powerful enough, under the right conditions, to throw a supermassive black hole out of its galaxy. For years, that was a prediction looking for a clean observation. Then came the new data. Using the James Webb Space Telescope, researchers examined the tip of the linear feature in much greater detail. And what they reported was exactly the kind of evidence the runaway black hole model needed. A sharp velocity discontinuity. Across a region only about a kiloparsec wide, the radial velocity of the gas changes by roughly 600 kilometers per second. That is not a subtle wobble. It is the signature of a violently disturbed environment. The team modeled the structure as a bow shock, the cosmic equivalent of the compressed wave that forms in front of a supersonic aircraft. Their best fit model suggested an object moving at about 950 kilometers per second, more than 2 million miles per hour. At that speed, the object is not peacefully orbiting inside a galaxy. It is escaping, and this is the key point. Astronomers do not see the black hole directly. A black hole moving through relatively empty space can be almost perfectly dark. What they see is the damage around it, the shocked gas, the sudden change in velocity, the compressed material, the narrow wake extending behind it. It is like detecting a bullet, not by photographing the bullet, but by mapping the air it tears apart. And that brings us back to the most counterintuitive part of the story, the stars. A black hole does not create stars from nothing. Instead, the proposed mechanism is compression. As the runaway object moves through the circumgalactic medium, it drives a shock into diffuse gas. Gas is heated, compressed, mixed, and then allowed to cool. In regions where enough material becomes dense, gravity can take over, clouds collapse, stars ignite, so the black hole's destructive motion may create the conditions for star formation behind it. This is why the trail matters more than the black hole itself. The wake is a record, a 200,000 light-year receipt showing where the object has been, and just like a financial chart can reveal the hidden behavior of a market participant, this stellar trail may reveal the movement of an object that is otherwise invisible. But there is a deeper question. How massive would the black hole have to be to sustain such a structure for tens of millions of years? The research team argues that the energy budget points to a mass of at least around 10 million suns. That estimate matters because it may tell us how the black hole was ejected. In a three-body slingshot, the lightest black hole is often the easiest one to throw out, but a black hole with a mass comparable to what you would expect from the former host makes a gravitational wave recoil after a black hole merger especially interesting. Imagine the sequence: two galaxies interact. Their central black holes sink toward the middle. The black holes spiral together. They merge. An enormous amount of energy leaves the system as gravitational waves. The emission is not perfectly symmetrical, and the remnant black hole gets kicked hard enough to leave home forever. Then, for tens of millions of years, it crosses the thin gas surrounding the galaxy, driving a shock and potentially lighting up a chain of new stars behind it. If that picture is correct, then we are looking at several of the most violent processes in astrophysics stacked on top of one another: a galaxy interaction, a black hole merger, a gravitational wave recoil, a supersonic escape, and then, unexpectedly, star formation. Destruction leading to creation. But here is where we need to slow down, because the most exciting story is not automatically the final story. The interpretation is still being challenged. Other astronomers have argued that the linear structure could be a thin edge-on star-forming galaxy rather than the wake of a runaway black hole. In 2026, a competing analysis of JWST spectra argued that key emission line ratios are consistent with low metallicity star-forming regions and do not uniquely require a shock. That does not erase the runaway black hole evidence, but it changes the way we should talk about it. The honest version is not case closed. The honest version is, one research team believes the velocity structure, morphology, and shock modeling strongly confirm a runaway supermassive black hole, while another team argues that at least some of the same spectral evidence remains compatible with a very different explanation. And that disagreement is not a weakness. It is the real frontier of science. The universe does not label its objects for us. Astronomers are reconstructing an invisible event from light that has traveled billions of years to reach Earth. They compare models, measure gas velocities, and search for predictions that one explanation can satisfy and another cannot. And whichever interpretation survives, the result will matter. If the runaway model wins, then astronomers may have identified the first clear example of a supermassive black hole fully ejected from its former host and detected through a supersonic wake that would prove that the central black holes of galaxies are not always permanent fixtures. Some can be expelled, some can wander, and some may be almost impossible to see unless they collide with enough gas to reveal themselves. That opens a much larger question. How many are out there? Galaxy mergers are common across cosmic history. Black hole binaries should form. Gravitational recoil is a real consequence of asymmetric gravitational wave emission. Three-body interactions are physically possible, so if one runaway supermassive black hole exists, there may be others crossing intergalactic space right now. Dark, massive, massive, nearly invisible. And if the edge-on galaxy explanation wins instead, that also matters, because it would show how easily an unusual galaxy can mimic one of the most exotic predictions in astrophysics. Either way, this object is forcing astronomers to improve the test: better spectroscopy, better spatial resolution, better models of shocks, star formation, and gas mixing. The reason this object was so difficult to find is simple. Long, faint, narrow structures are easy to miss. But once you know what pattern to search for, wide field surveys and automated detection tools can begin looking for more. That is often how a new field begins: first, one strange object, then a candidate population, then a new category of the universe. For now, the most powerful idea is also the simplest. A black hole may have been thrown out of its galaxy at nearly 1,000 kilometers per second. Its motion may be compressing gas. That gas may be cooling. And in the wake of an object famous for swallowing stars, new stars may be forming. There is something almost poetic about that, but the science is even better than the poetry, because this is not a story about the universe being peaceful. It is a story about how violence changes the conditions of what becomes possible. A collision can create a merger can create a recoil can create a recoil can create a shock can compress gas, and compressed gas can create stars. The universe does not divide destruction and creation as neatly as we do. Sometimes they are the same process, viewed at different moments, and somewhere billions of light years away, a thin line across the darkness may be showing us exactly that.